Hello everyone, this is Yujie Hao. Today I will demo Java applet for the course Object-Oriented Programming in Java, which is provided by UCSD in Coursera. I've learned C++ before, and I learned Java by myself. So I take this course just for review, some basic object-oriented programming, and then also try to do my first data visualization project. So this project is pretty cool. I review a lot of basic stuff. If you haven't learned OOP programming before, so this course will be a good starter. If you learn it, it's also a cool course for you to create the map related project. This is also my first Google Map project. So let's see. This is my README file for this project. So basically, this application is a Java applet which we can embed it in a web page and then let user to browse it through a web browser. It's a data visualization project, and then it's a user interactive earthquake map, which can provide earthquake information and the city information and even airport information. So this Java applet uses the processing library, which is also a graphical language that can draw some different shapes or place some text in the map. And it can also capture the mouse event like mouse click, mouse hover, and then also can capture the mouse X and Y coordination. And you use the unfolding maps as the map feed for this application. You can use Google Map, Microsoft Map, Yahoo Map. If you need more information, you can read this URL. And then for fetching the data, we fetch the earthquake information from this URL, which is a atom file, which is like XML file, and then it's a text-based data file. And we get the airport information from this link. Let's have a quick look. So the earthquake is from the USGS. We captured the 2.5 plus earthquake happened the past week. And then this is the airport information website. If you click here, you can see the DAT file. You see here. These are all the airport information with the airport name, airport abbreviation code. I think it's called ITAT code or something. And then it's latitude and longitude and country, city name, like that. This is the UML diagram that I draw for this project. You can see the root object is the marker, which has a lot of marker features. And then these three are the markers that inherited from this common marker, which is provided by UCSD MOOC team. So these different markers have different draw method and then different shape. And then for the ocean quake marker and land quake marker, they are inherited from the earthquake marker. So these two also have different shapes. So these demonstrate the inheritance hierarchy, and then also we use a polymorphism mechanism, which is use the parent reference to point to the subclass object. So when we call parent class.draw method, it will actually, in the runtime, it will call the subclass draw method, which is overridden for the parent draw method. And then you can see a simple polygon marker here. So this marker is the country marker, which shows in the map like different countries, different shapes. Actually, I tested this the polygon marker. I just like paint China or Russia or America as different color. I can see the map is covered by a whole block of different colors. So the purpose of using this polygon marker is that we can judge if a certain earthquake, which is an earthquake marker, is it inside a polygon marker. If it's inside the polygon marker, we know it's inland. If it's outside of a polygon marker, then we know it's in the ocean. So then we can tell it's an ocean quake marker or a land quake marker. This is very interesting, and then it's good for the student to learn how to draw the UML diagram. It illustrates very well. So this is also an event-driven application, which when user hover on a city marker or when user click on a certain marker, it will trigger a certain event, and then it will call a certain function. And then also, we will sort the top 20 earthquakes that happens recently, because the earthquake marker implements the comparable interface, and then it overrides the compare-to method. So when we call the arrays.sort, internally it will use the compare-to method to compare earthquake by earthquake. Then it will do a descending order sort, so it will print out the different earthquakes in a descending order. So now let's just play the app. So you can see this is the recent 20 earthquakes in a descending order. And then this is the actual applet. You can see in the left side, this is the marker's illustration. So the bigger the marker it is, the larger the magnitude it is. So from the map, you can see this earthquake is bigger than, this ocean quake is bigger than this ocean quake. And then this ocean quake is bigger than this ocean quake. Or some land quake, you can say this land quake is bigger than this land quake. You can tell from the size of the shape. And for the color, the more red it is, the shallower the earthquake it is. Like these red earthquakes are very shallow earthquakes, which has a larger damage to the people. And then you can say this one, like the purple one, if they're the same size, I mean, then means this one is deeper. So purple, the pure purple one, means it's deeper than 100 kilometers. So actually this earthquake is the same size as this earthquake, or say landquake. So they are the same size, which means they are the same magnitude, but this color is more purple. So this one has a less damage than the orange one, because the orange one is shallower. And you can see different shape. The round shape means landquake. The orange shape means the ocean quake. Actually, I should change the name to landquake rather than earthquake, because both landquake and ocean quake can call as earthquake, because they all happen on the earth. So landquake and ocean quake. And then the city shape is triangular. Let's say this one is Santiago in Chile. So this is a city. And they happen in a different time. So I will just mark a letter on it. Because this data is fetched from the website within weeks. So you actually won't see letter M or Y. But if we use a different data file, you can see that. So actually you see this one, W. This one happens last week. And then let's see, I see a letter D here. I see a letter D here, so this means it happened last day. Okay. And this map also could respond to the key event. Let's say I press minus, it will zoom out. If I press plus, it will zoom in. If I press up and down, right and left, it will move. So I prefer using keyboard because it's more accurate than the mouse. So let's say I hover on Bangkok. You can see it will show the city information inside a box. Bangkok is in Thailand and the population is 8 million plus. If I see, let's say, hover on Singapore, then you can see the population is 5 million plus. So this is a hover event. If you hover on the ocean quake, you can see its information. Land quake, same thing. Okay, so that's the hover event. What about click? If you click, let's say I click on Bangkok, you can see these two earthquakes is connected with two lines to Bangkok because I use a formula called threat circle. This formula is provided by UCSD, so you can simply say the bigger the magnitude it is, then the wider the threat circle it will be, the wider range it will cover. I don't know how they come up with this formula, maybe from some earthquake website or from some research. So you can see these two earthquake threats the Bangkok. So Bangkok is within the threat circle of these two earthquakes. If you click the earthquake, you can see how many big city or major city that I marked triangular is affected by this earthquake. If I click this earthquake, you can see, oh, there are two cities, Singapore and Bangkok, are affected by this earthquake. So this is the click event. And also, if you click the city, you can see, let me zoom in, you can see some green dot here. What are these? Actually, these are all the airports that I fetched the data from the website I just showed you. These are all the airports within 200 kilometers of the city. So if you click the city, you will see the airport. Let's see Hong Kong. Oh, it has many airports around it. Okay. So the airport information and the GUI here I draw is different from the demo GUI that UCSD provided. So these two features are actually the extra credit that I want to get from this project. I spent some time in it. Okay. If I update the URL to this one, it will also show all the earthquake happened in the past month, no matter what magnitude it was. So the map will have more data. You can see there's some earthquake happened in the past month. And then one more feature that I added is this button. If we click this button, it will show the country that suffers the biggest earthquake in the past month. So when I do the sorting, I get the biggest earthquake and then check if it's inland. If it's not, I will skip it and then go to the second biggest earthquake, so on and so forth, until I iterate through all the earthquake array list and then find the biggest landquake, and then find the landquake's property, which is the country name. And then I will get that name and then iterate through the country marker. Then I will get the country the polygon, and then I will draw that polygon to red color. Okay, so this is my earthquake applet. I like it very much. I highly recommend this Java course to other students. Thank you. Bye-bye.